नमस्कार बच्चों, मेरा नाम है धन्या और हम लोग आज सीख रहे हैं ग्रेड 11 केमिस्ट्री का फर्स्ट लेसन सब बेसिक कॉन्सेप्ट्स ऑफ केमिस्ट्री। ओके, सो मेरे पहले वीडियो में आप लोगों ने 5 लॉज देख लिए होंगे। ओके, ये मेरा दूसरा वीडियो है और इसमें आज हम लोग परसेंटेज कॉम्पोजिशन, मोल कॉन्सेप्ट एंड स्टोशियोमेट्री, लिमिटिंग रिएजेंट, एम्पिरिकल एंड मॉलिक्यूलर फॉर्मूला ये सीखेंगे। Okay, so in between you will be doing some NEET question, past paper questions. After completing the whole lesson, I'll be doing some past paper questions. Okay, so let's get started. Right now, so molecular mass of calcium carbonate. अगर आपसे पूछा जाए तो calcium carbonate is the compound. It is made up of calcium, carbon and oxygen. So molecular mass means you are just adding up the masses of different elements. Okay, so calcium is 40, carbon is 12, oxygen is 16. Okay, so calcium कितना हुआ 40 plus carbon कितना हुआ 12 plus oxygen is how much 16, and there are 3 atoms of oxygen, so 16 times 3, so 40 plus 12 plus 48. Okay, so 88 plus 12, that's equal to 100 grams. Okay, so this is how you find out the molecular mass. Let's do one more compound, okay, because this is important in the formula, right? So molecular mass of ammonia. Nitrogen is 14, hydrogen is 1. So masses are, it will be given to you in the exam, and as I told you in the previous video, when you do different questions, it will automatically come to your mind. Okay, so nitrogen is 14, hydrogen is 1, but how many hydrogen atoms are there? 3 hydrogen atoms, right? So 14 plus 3 equal to 17 grams. So this is how you find out the molecular mass. So it is just you're adding up the masses of different elements in that compound. Okay, so this is how you find out the molecular mass. Let's come to percentage composition now. Okay, what is the formula for percentage composition? Equal to, basically you're finding the percentage of an element in that particular compound. Okay, so mass of element by mass of compound because you're finding out the percentage, definitely you have to multiply with 100. Okay, now the first question is, so you have to memorize this formula, right? Now the first question is the question that was given in the PowerPoint. I just write it over here. You need to find the percentage composition of first one, calcium in calcium carbonate. Okay, so calcium is 40, oxygen is 16, carbon is 12. So this is the formula. I have written it. This is the formula. I'm keeping it as it is. Okay, up. Calcium. So mass of calcium. So mass of the element, mass of calcium is how much? There's only one calcium atom, so it is 40, right? And mass of compound, calcium carbonate is the compound, right? How much is the mass? Calcium carbonate का mass कितना है? We found out just a while ago. फिर भी एक बार और find out कर लेते हैं. 40 plus carbon is how much? 12. Oxygen is how much? 16. But how many atoms are there? 3 atoms, which gives equal to 100. चलो percentage composition of calcium. How much is the mass of the element? 40 over. How much is the mass of the compound? 100 times 100. Percentage का जो हम लोग डालते हैं. Okay. So, which is equal to how much? 40% of calcium is there in calcium carbonate. Okay. So, this is how you find out the percentage of a certain element in a compound. Okay. Let's do another example. Second one is hydrogen in sulfuric acid. Okay, hydrogen is 1, sulfur is 32, oxygen is 16. Okay, अब mass of hydrogen कितना हुआ? Mass of hydrogen, it is 1, but how many hydrogen atoms are there? 2. So, which is equal to 2. Mass of the compound sulfuric acid, total mass कितना हुआ? Hydrogen is 1 times 2 because there are 2 hydrogen atoms, plus sulfur is how much? 32, plus oxygen is how much? 16 times 4 because how many oxygen atoms are there? 4 hydrogen atoms. Sorry, 4 oxygen atoms are there. So 2 plus 32 plus 64. It's 98, right? So percentage of hydrogen. What is the mass of hydrogen? 2 over. What is the mass of the compound sulfuric acid? 98 times 100. Okay, so 200 over 98. So you can find out whatever answer you get, you have to express it in percentage, right? Now, we'll do one more and let's move on to the next question, okay? So you just have to find out. So third one, nitrogen in ammonium hydroxide, okay? Now, mass of nitrogen कितना हुआ? Mass of nitrogen, sorry, nitrogen 14, oxygen is 16, hydrogen is 1. Okay, so mass of nitrogen is 14 because there's only one nitrogen atom over here, right? Then mass of the whole compound ammonium hydroxide कितना हुआ? Nitrogen is 14 plus 1 is the mass of hydrogen. यहाँ पे कितना हुआ? 4 plus 1, 5, right? Plus oxygen is 16. There's only one oxygen atom. So 14 plus 5 plus 16. So it's 35, right? So mass, sorry, percentage of nitrogen equal to mass of nitrogen is how much? 14 over total mass of the compound is 35 times 100. So whatever answer you get, you have to express it in percentage. Okay? Percentage of nitrogen. I just reshare it again. It's not I'll just share the screen again. Okay. So the percentage of this is 35. Percentage of nitrogen is equal to amount of nitrogen, mass of nitrogen over total mass of the compound times 100. So whatever answer you get, you have to express in percentage. Okay. So sometimes in competitive exam, they might ask you. Okay. So this is just direct application of the formula. That's it. Okay. So students, this is how you find out the percentage composition. So this may come as a scoring question. Okay. So we finished with the first topic, percentage composition. Okay. Now, in the second topic, we will be dealing with the mole concept. Okay. The mole concept. Now, this mole concept is a lot of questions you get for the competitive exam in mole concept. Okay. Now, just asking you before I start, just asking you, atoms are very small particles, right? Atoms are very, very small particles. Molecules are very small particles. So in order to express the number of particles, it is very difficult to express the number of particles if we just say if 1 gram of any substance has how many particles. So it is very difficult because there may be many particles because the atom size or a molecule size is very, very small. So just like we take as, so scientists developed a particular concept called the mole concept. Just like we express like 1 dozen of orange or 1 dozen of apple, how many oranges are there in 1 dozen? It's 12, right? Or 1 dozen of apple, 12, right? So same way, scientists developed the same concept over here. They express the atoms and molecules in terms of moles. Okay, now I'll just share the screen again. Now, according to the mole concept, according to the mole concept, 1 mole, just like 1 dozen has 12 oranges. 1 dozen means 12 oranges or 12 apple or 12 units, we can say. Same way, 1 mole of any substance contains equal to 6.023 10 raised to 23 atoms or molecules or ions. Ions, we will, as we move on, they are just charged particles. As we move on, you will be learning more about it. I know a little bit of it you have learned in grade 10, but then we will be learning about it. Okay, ions are just charged particles. Okay, like Ca2 plus or Na plus. So those having charges are called as ions. Okay, now just as 1 dozen has 12 oranges or 12 units or 12 apples, same way 1 mole of any substance is a group of 6.023 times 10 raised to 23 atoms or molecules or ions. If we are talking about atoms, there are 6.023 into 10 raised to 23 atoms. Okay, and this number 6.023, in some books it is 6.022 also. Sometimes the values are given. Okay, 6.023 times 10 raised to 23. This is called as Avogadro number. Avogadro's number. Okay. Now this value 6.023 into 10 times 10 raised to 23 is called as Avogadro number. Okay. So 1 mole of any substance, 1 mole of any atom, 1 mole of any substance contain Avogadro number of particles. It can be atoms, ions, or molecules. Right? Now, Related to this, you just have to remember 1 mole is just as 1 dozen has 12 apples. So 1 mole has Avogadro number of particles, can be ions, atoms or molecules, right? Now, over here, just wanted to tell you a small relationship which you have to remember, okay? Just a shortcut type of a thing. 1 mole of any substance, okay, is equal to, contains how many particles we just saw now? 6.023 times 10 raised to 23 particles I'm writing. Okay, can be atoms, molecules or ions. Okay, and it weighs, what is the weight of this many particles? What is the weight of 1 mole of any substance? Or what is the weight of 6.023 times 23 particles? Is equal to molecular mass, if it's a molecule, or atomic mass, if it's an atom. Okay, and it occupies the volume of 22.4 liters. I'll just show with an example now. 22.4 liters. Okay. Now I will discuss one with atom and one with molecule. Okay. Suppose 1 mole of sodium atom. Sodium, the atomic mass is 23. Okay. This is just a shortcut to remember to do the sums, etc. Okay. 1 mole of any substance, 1 mole of, suppose sodium atom I'm writing, will have how many atoms? 6.023 10 raised to 23 atoms of what? Atoms of sodium. Right. Now, what is the weight of the sodium atom? It is, I've already given 23. It weighs equal to 23 grams. That is just the atomic mass of sodium. Okay. And what is the volume occupied by 1 mole of sodium atom? It is 22.4 liters. And this 22.4 liter is called as molar volume. You need to memorize it and keep it in your mind because a lot of questions is asked based on this, right? Similarly, I'll take another example of a molecule or a compound, okay? 1 mole of maybe calcium carbonate. We just did calcium carbonate. We know the molecular mass. Okay. So calcium, for you to find out, calcium is 40, carbon is 12, oxygen is 16. Okay. So 1 mole of calcium carbonate contains how many molecules? 6.023 times 10 raised to 23 molecules of what? Calcium carbonate. What is the weight? You just have to find out the molecular mass. How much it is? Calcium carbonate, the molecular mass, 40 plus 12 plus 16 times 3 equal to 100 grams, right? So it weighs equal to 100 grams. It's nothing but the molecular mass, right? We just found out a while ago in the previous slide, right? And how much volume does it occupy? 22.4 liters. And it is called as molar volume. If you keep this in your mind, a lot of sums you can solve easily. Okay. So students, 1 mole contains 6 points Avogadro number of particles, weighs equal to the atomic mass if it's an atom, molecular mass if it's a molecule or a compound. And how much volume does it occupy? It's a standardized thing, 22.4 liters. And what is that value called? 22.4 molar volume. Okay, because it is the volume occupied by 1 mole of any substance. Similarly, the atomic mass, I'll just rub off this one. Similarly, atomic mass or molecular mass is called molar mass because it is the mass of 1 mole of any substance. So, students, you will come across the word called molar mass. Molar mass means mass of 1 mole. As you can see over here, 23 grams is the molar mass of which one? Sodium. Molecular mass is molar gram because I've expressed it in grams. Okay, so molar mass is nothing but the mass of 1 mole of any substance. And molar volume is the volume occupied by 1 mole of any substance. Right? Moving on further, this 1 mole of any substance contains 6.023 times 10 raised to 23 particles. I'm just writing as generalized form particles. And you know it can be atoms, molecules or ions. Okay. And weighs equal to molar mass or molecular mass or atomic mass and occupies a volume of 22.4 liters, which is called the molar volume because it occupies the volume occupied by 1 mole of any substance. Okay, and this can also be called as molar mass because it is the mass occupied by 1 mole of the substance or the mass of 1 mole of the substance. Now, apart from this, you have to remember 2 more formulas. Don't worry, it's very easy formula. Mole can, apart from this relationship, mole can also be found out if the mass is given in grams, mass in grams, kg also if it's given, you can convert it into grams, okay, divided by molecular mass or molar mass. Okay, why in grams? Because the molar mass is expressed in grams, mass of 1 mole of any substance. Okay, so this is one relation. If you are given the mass in grams and you know which molecule it is or which atom it is, you can easily find out the molar mass or the molecular mass. We did it beginning of the lesson. Okay, you can easily find out the mole. Okay, similarly, if the volume is given at STP, volume is given at STP, volume of any gas is given in STP, you can find out the mole by this formula, volume given in the given volume in STP by molar volume. How much is the molar volume that we learnt just now? What is the molar volume that we just learnt now? 22.4 liters. Okay, so these are the 2 formulas that you need to keep it in your mind. So if the mass is given in grams, you know which compound or which molecule it is, you can find out the number of moles. Similarly, you can also find out the moles when you are given the volume in STP. You know the molar volume, you have to memorize it, 22.4. When you divide it, you get the number of moles. So these few things, if you remember, you can do a lot of questions. Okay, some questions are in the competitive exam are based on these. Okay, so we will we'll start with some basic questions. Okay, right. So this is what we did. You have to remember the Avogadro number, and also you have to remember this molar volume, which is equal to 22.4. Okay, 22.4 liters. That is a molar volume, 22.4 liters. Right. Now coming to some questions. So this formula I already gave. Along with this, I already told you molar mass means it's the mass occupied by 1 mole of any substance. Okay, so that's the molecular mass that you find out. Okay, or the atomic mass. Now, I already explained these formulas also. For if the volume is given at STP, you can easily find out the number of moles. Okay. Now we have done this formulas. Now moving on to some questions. Okay. So these are some of the questions, and in this you can see some of them are NEET questions also. So a lot of questions from this lesson, from this topic. Okay, so in today's lesson, we will be doing few of them. But as I told you, after I finish the whole lesson, I will be practicing. One video will be full of practicing the past papers based on this lesson. Okay. So these are the questions, as I'll do it in the whiteboard. Okay. Now, the first question is, find the number of moles. So I'm not writing the whole question. I'm just writing the information that's given and what is the question. Okay, because you can take screenshot of the questions I showed it a while ago, right? So you have to find out the number of moles of 120 grams of calcium. So calcium is 40. So you are being provided with, and I'm writing the formulas over here, okay? So moles is mass in grams by molar mass. That is one of the formula, right? Another formula is moles equal to volume at STP. That's given, that would be given to you, or you have to find out, by molar volume, which is equal to 22.4, right? And 1 mole has how many particles? 6.023 into 10 raised to 23. Okay. Now, these are the formulas. Okay. Now, in this case, moles of 120 grams of calcium. Okay. So do you have a formula in your hand? Mass in grams is given to you, right? So how do you find out the moles? Moles equal to mass in grams over molar mass. Molar mass is nothing but the atomic mass or the molecular mass of a compound. Okay, if it's an atom, we consider the atomic mass. I have already given it to you. Calcium is 40. Okay, now mass in grams is given to you 120 over 40. So if you solve it, it comes to 8 grams. Sorry, it's not grams. It is 8 moles. Moles doesn't. It is just a. It's just the moles has the unit of moles only. Okay, so it is 8 moles. Second question is, this is the first part. Second one, you have to find the number of moles. This is question number 1. Second one is, you have to find out the number of moles in 56 liters of carbon dioxide. Okay, if it is not liters, you have to make it into liters. Okay, because the molar mass is expressed in 22.4 liters. So how to find out the number of moles? Is moles, and they have given at STP. Okay, so moles is equal to what? Volume at STP over, what is the molar volume? 22.4 liters. So is it given to you? 56, right? By 22.4, which is equal to 2.5 moles. It's not grams, it's moles. Okay. So these are some of the basic questions. Okay. Now, so just write down the question. I've written it over here. Now, I hope this is clear. So this was just basic application. This was just the basic application of these formulas. Okay, direct application of the formulas, right? Now, coming to the next question is question number 3. Okay, you need to find the number of molecules in 34 grams of ammonia. All right, I've written down the question over here. So, now, nitrogen is 14, hydrogen is 1. Okay, here the mass is given to you. You can find out the moles, right? But what they have asked is number of molecules. Okay, so number of molecules, we know one information. 1 mole contains 6.023 into 10 raised to 23 molecules. Okay, this information we know, right? Now, in ammonia, moles of ammonia. Can we find out the moles of ammonia? Because we know the mass in grams, mass in grams over molar mass. Mass in grams is given to you, right? 34. What is the molar mass? So I'm just doing it directly. Ammonia 14 plus hydrogen is 1 times 3. That is 34 over 17, which is equal to 2 moles. So you have the moles in your hand, 2 moles, right? Now, coming back to this information. 1 mole contains how many particles? 6.023 times 10 raised to 23 particles or molecules in this case, molecules of ammonia, right? Because we know it, we just write it as molecules, okay? So for 1 mole has 6.023. So for us, how many moles are there? So 2 moles will have how many? X. So I can do it directly. I'm just doing it as a cross multiplication because as we move on in the lesson, a lot of questions we can do is do like this as a cross multiplication. It's easier. Okay. So 1 mole, that will be your first statement. 1 mole has Avogadro number of particles. So 2 mole will have how much? That's X. So when you cross multiply, X times 1, I'm writing it as X, 2 times 6.023, 10 raised to 23, which is equal to how many particles? You just have to multiply it, okay? 6.023 times 10 raised to 23. So 6, 4, 0, 12. 10 raised to 23 particles, molecules in this case. 23 molecules. So this is how you find out the number of molecules. So this type of questions comes a lot, okay? Especially, we will be doing it as we move on in the lesson, okay? Now, so this is how we do it. So they have asked you the number of molecules. So first you find out how many moles are there and write down the first statement. 1 mole has Avogadro number of particles. So 2 moles will have how many? And just you cross multiply it, right? So I hope till now it's okay, right? So these are small, some tricks to solve the question, okay? Now, moving on further, question number 4, okay? Find the mass of, you have to find the mass of 11.2 liters of nitrogen molecule. This is mass, and they have given the volume at STP. The volume is given at STP, right? Now, volume is given to you. If volume at STP is given to you, can you find out something? Can we find out the number of moles? Do we have the formula of moles over here when the volume is given at STP? So moles equal to volume at STP over molar volume, that is equal to 22.4 liters, right? So 11.2 over 22.4. How much do you get? This is the number of moles. Now, this is equal to 0.5 mole. If you know the moles, okay, and you know which molecule it is, nitrogen, right? Nitrogen is 14. Nitrogen is 14. The mass. Okay. If you know the molecule, which molecule it is, can you find out the molar mass? It is 14 times 2 because there are 2 nitrogen atoms, right? Now, and you know the number of moles, it is equal to 0.5 moles. Okay. So, what is the question? We need to find out the mass. This is the question. Find the mass. Okay. So, mole equal to mass over molar mass. You know the number of moles. Mass, and keep it as X, and molar mass is 28. So how much is the mass? 0.5 times 28. So whatever is the answer, you write it in grams. Okay. 18. So it's 11 grams, right? So this is how you find out the mass when they have given you the volume. Okay, so they might give one value, and from there you can find out another value, right? Now, let's move on to the next question. The next question is, maybe the question number, I'm writing it as wrong because I'm just solving you can take the screenshot of the PowerPoint, the questions in the PowerPoint, okay? So the next question is, you need to find the volume. Find the volume of 32 grams of SO2 at STP. And sulfur is 32. Okay. So mass in grams, just the opposite of the other one. Okay. Just the opposite of the other one. Sulfur is 32, oxygen is 16. Similarly, just try out. From here, can you find out the number of moles? Number of moles is, you know the mass in grams. Okay. Molar mass you can find out. It is sulfur dioxide. So mass in grams is how much? 32. Formula is written here. So I'm just doing it directly over here. Mass in grams over, so this is the mass in grams, over sulfur dioxide. Sulfur is 32 over 16 times 2. 32 over 64. Right? 32 over 64, which is equal to 0.5 moles. So I just used the first formula. Moles equal to mass in grams over molar mass. Now you know the number of moles, 0.5 mole. right? What do you have to find out? Volume. So can we use the second formula? Mole equal to volume in liters at STP is already given to you, so we don't have to worry as STP. And what is the molar volume? It is 22.4 liters, right? So mole is 0.5, volume I'm keeping it as X over 22.4. So X is equal to 22.4 times 0.5, which is equal to 11.2 liters. Okay, so this is how you find out. If mass is given to you, you can find out the volume and vice versa. Okay, so this is how you do the question. Okay. Next one is one of the NEET question. Okay. Sometimes they give us to solve it and write down the answer. Sometimes there's a multiple choice question also. Now, the first question is, the question is the highest number of helium atom in, these are the options, 4 mole of helium. Second one is 4 U of helium. C is 4 gram of helium. D is 2.27 liter of helium at STP. Two point 2.7 liter of helium at STP. So here you need to find out the highest number of helium atom. Okay. So I'm just rubbing this formula for some time. Okay. Now 4 mole of helium. So we already know 1 mole has 6.023 times 10 raised to 23 particles, atoms, or okay, in this case atoms because it's helium atom, right? So let's find out one by one. Case A. Okay, 1 mole, we did this type of question. 1 mole has 6.023 times 10 raised to 23. So 4 mole will have how much? So X is equal to 4 times 6.023 10 raised to 23. Okay, so this is 24. So X is equal to 24.0292 10 raised to 23. So these many atoms are there for helium. Okay. Second one, 4 U of helium. Now, it's a small information that I want to pass on. Okay. We just referred to the molecular mass, right? Molecular mass we studied, right? Now, students, whenever I have molecular mass, if it is given in grams, okay, whenever the molecular mass is given in grams, now students, please remember this information. Whenever molecular mass is given in grams, okay, it contains 6.023 times 10 raised to 23 particles. Okay. Now, that's the Avogadro number of particles. Whenever it is given in molecular or atomic, okay, molecular or atomic mass, atomic or molecular mass, atomic or molecular mass is given in AMU or just U, it contains one atom. This is another information that you must keep in mind. Mostly they give in grams only, okay. In this particular case, they have given in U, so I thought I should keep you informed. So when molecular atomic mass is given in grams, this you already know, it contains 6.023 times 10 raised to 23 particles. Okay, that's the information that you know already, molecular mass, molar mass, okay. But if the atomic or molecular mass is given in AMU, that means it contains how many atoms? One atom. Okay, now over here, the mass of helium is already 4. Okay, now 4U is already the mass. 4 is already the mass. So 4U means how many atoms does it have? It is equivalent to 1 atom of helium. Because 4U is the mass of 1 atom of helium. Okay, so as you already know, if it is expressed in AMU or U, it is equivalent to 1 atom. And 4 is the atomic mass. It's already the atomic mass of helium. So if 4 is the atomic mass of helium, then 4U means how many atoms does it have? 1 atom of helium. Now, let's move on to the third one, 4 gram of helium. 4 gram means you have to find the number of moles first. Moles of helium. You already know how to find the moles of helium, 4 grams. Or rather, we can do it in another way also. Four grams contain, 4 is the atomic mass of helium, 4 grams, right? So it will contain how many particles? 6.023 10 raised to 23 particles. See, it's in grams. See, both of them is practiced. If it's given in grams, it contains 6.023 times 10 raised to 23. And 4 is already the atomic mass of helium, right? And if it is given in AMU, it is equivalent to that particular mass, molecular mass is equivalent to 1 atom. And 4 is already the atomic mass of helium. That refers to 1 atom of helium, right? So if we have the mass given in grams, it will be equivalent to how many? The Avogadro number of particles. Now, the next one, 2.27 liters of helium. So 2.27 means how many particles does it have? How do you find out this one? You need to find the number of moles first. So moles is equal to how much? 2.27 over 22.4. Right? So 1 mole has 6.023 10 raised to 23. So I'm rubbing off this one. I need a little bit of space. So you need to find the number of moles. 2.27 over 22.4. So 1 mole contains 6.023 raised to 10 raised to 23. And 2.27 over 22.4 is 0.101. Okay. So 0.101 will have how much? X is equal to 0.101 into 6.023 10 raised to 23. particles. Okay, this is 0.610 10 raised to 23. So we have first one, this is one atom. So what will be your answer? Which one is highest? So definitely 4 moles because it is the highest, right? Yes, so A is the answer. So this is how you solve, okay? And this particular information you must keep in mind that the molecular mass or atomic mass is given in grams. It is equivalent to 6.023, the Avogadro number of particles. It is given, if it is given in U, it is equivalent to 1 atom. For example, I hope you have done this, right? I'll just refer to as one example. For example, the atomic mass of calcium is 40. That's a common example we'll be doing, okay? Calcium is 40. Atomic mass of calcium is 40. So 40 grams, that's atomic mass, okay? Will have how many particles? 6.023 10 raised to 23 atoms of calcium. Because it's expressed in grams. Okay. But the same thing I express in 40U means 1 atom. The same thing I did in the previous question. Okay. So AMU, usually mostly grams are used, but sometimes they might give as a, option. So you have to understand and do it. Okay. Now moving on further. So this is what was one of the NEET question. Similarly, students, one more question. This is also one of the competitive exam question. Which one weighs most? First is 0.1 mole of calcium, 5.6 liter carbon dioxide, 6.022 10 raised to 23 atoms silver. We have not come across silver. Silver is 108, calcium is 40. Okay. Now, over here, these are the 3 options. Which one weighs most? You have to find the mass. Okay. So you already know mass is how much? Mole time. So I'm doing it directly. Mole time, the molar mass or the atomic mass. How many? What is the number of moles? So I'm just using the formula mole equal to mass over, using the formula mole equal to mass over molar mass. So mass, how to find out the mass? Mole time, molar mass. Right. So over here moles are given to you and calcium is 40. Okay. I've shown it over here. So how much it is? 4 grams weight. Okay. So sometimes they might ask you which one has more weight, which one has more number of atoms, particles, etc. Okay. So these are some of the common questions you must be prepared. With. Okay. So the formulas, if you memorize it quickly, you can solve it. Now, 5.6 liters of carbon dioxide. So which formula I should use? Mole equal to volume over 22.4, volume at STP. Volume is given to you. So 5.6 over mole equal to volume is 5.6 over 22.4. Okay. So this is equal to 0.25. So how to find out the mass? Mass equal to mole time, molar mass. How to find out the mass? Mole time, molar mass, I've already done written it over here. So 0.25 over carbon dioxide. Carbon is 12, oxygen is 16. So carbon is 12 plus oxygen is 16 times 2, 32. So 0.25 times 44, which is equal to 11 grams. Okay, third one. 6.022 times 10 raised to 22 atoms of calcium. So 1 mole, or rather you can do it in another way. We already discussed atomic mass or molecular mass in grams, or 6.023 times 10 raised to 23 weighs equal to molecular mass in grams, right? So 6.023 times 10 raised to 23 weighs equal to how much? 108 grams. So this is, as I told you, in some of the books they give as 6.022 or 6.023. So this mass, this number of particles is equivalent to how much? The molar mass or the atomic mass of silver. I've already mentioned the atomic mass of silver. It is 108, right? So this is one way of doing it directly. You can also do it in another way. I'll just share the screen again. There's another way of doing it, okay? Like 1 mole has, this is a little bit lengthy way, so I just try to do it directly. 1 mole contains 6.022 times 10 raised to 23. Okay, so mass over molar mass. What's the molar mass? 108. Which is equal to number of moles is 1, because 1 mole already has this. Now, so students, this is what we did. Okay, so we already know the information. 1 mole of any substance contains 6 Avogadro number of particles, and it weighs equal to the atomic mass or molar mass in grams. So here I already mentioned the molar atomic mass of silver. It is 108. So 6.022, that's also Avogadro number. As I told you, in some books it's 6.022, in some books 6.023. So they have already mentioned. So Avogadro number of particles weighs equal to the atomic mass. Okay. Now let's check out which one is weighing more. We have, this is A, this is B, this is C. This is one of the NEET questions. Okay, so we have C is the right answer. Okay, so students, you have to know the formulas as well as some informations like 1 mole contains Avogadro number of particles, weighs equal to the atomic mass or molecular mass in grams. And if and I already explained if it is in AMU what to do. Okay, so these were some of the questions. Some NEET questions were already there. I have the burning of methane in oxygen to give you carbon dioxide. water. Just balanced it. Okay. 16 grams of methane burns. 16 grams of methane burns. You need to find out the amount of carbon dioxide that is produced. Okay. Now, for this, I will go with the mole concept. Okay. You already know the formula. How to find the moles. Mole equal to what? Mass in grams over molar mass. Right. Over here. So 16 grams of methane is burning. I have 16 grams methane. First, I need to look at the stoichiometric coefficients. The stoichiometric coefficient are nothing but these balancing numbers. So they are talking about methane and carbon dioxide. So we need to look at the balancing numbers of methane and carbon dioxide. Right. For methane, if no number is there, that's equivalent to 1. It cannot be 0. Okay. Here also the balancing number is 1 since no number is mentioned. Right. Now here, this is the equation. So they have already told you 16 gram of methane is burning. You need to find out the mass of carbon dioxide from the equation. That's what you need to find out. Okay. Now, 1 mole, the stoichiometric coefficient 1, we consider as mole. Okay. Assume 1 mole is reacting with 1 mole of carbon dioxide. Okay. But we already know the mass of methane. We already know the mass of methane is 16 grams. Can we know the moles of methane? Do we have the formula in our hand? Mole equal to mass in grams over molar mass. So mass in grams is 16 over. The molar mass is how much for methane? Methane, it is CH4. So 12 plus 1 times 4, because there are 4 hydrogen atoms, right? 16 over 16. That is equal to how much? 1 mole. So if 1 mole of methane from this 1 mole is the stoichiometric coefficient of methane, is reacting with 1 mole of carbon dioxide. So the given amount of methane is 16 grams. From there we found out the moles. How much mole we found out there? So 1 mole of methane will react with how much? That is equal to 1 mole of carbon dioxide. This is moles. Okay. You have to find out the mass. So mole, again we use the same formula. Mole equal to mass over molar mass of what? Carbon dioxide. Because we need to find the mass of carbon dioxide. We have the number of moles, that's equal to 1. Mass, we don't know. Molar mass is, carbon is 12, oxygen is 16. So 12 plus 16 times 2, which is equal to 44. So 1 times 44 equal to the mass. Mass over 44. So mass is equal to how much? 44 grams. This is how you find out from the equation. Okay. Now, similarly, the next question. Find the volume of carbon dioxide produced when 50 gram of calcium carbonate is heated. Calcium is 40, carbon is 12, oxygen is 16. Okay. So first, always writing the balanced equation will be your first step. Okay. So calcium carbonate is heating. On heating, give you calcium oxide and carbon dioxide. Okay, it's already balanced. Oxygen is 3, calcium is 1, carbon is 1. Okay, you need to find the volume of carbon dioxide gas. Now, what is given to you? They have given you information about calcium carbonate. You need to find the volume of carbon dioxide. Okay, what information given is the mass of calcium carbonate, right? Now, from the mass of calcium carbonate, which is equal to 50 grams, can we find out the moles? Moles equal to mass over molar mass. By now, you would have, that would be by heart, right? Moles equal to 50 over molar mass is how much? Calcium is 40, carbon is 12, oxygen is mass of calcium carbonate given is 50 grams. That's given. Okay. We can find out the moles. Mass is 50 over molar mass is how much? Calcium is 40, carbon is 12, oxygen is 16 times 3 because there are 3 oxygen atoms. This is equal to 0.5 moles. Okay, so balancing numbers between these two, because we are talking about calcium carbonate and carbon dioxide. So 1 mole will give you 1 mole of carbon dioxide from the equation. Okay, from the balancing numbers. But we already know the number of moles of, actual number of moles of calcium carbonate, which is equal to 0.5, will be how much? X. So X is equal to 0.5 times 1, which is equal to 0.5. This is the number of moles of what? Carbon dioxide, which is equal to 0.5. Now, this is the number of moles. What they have asked is the volume. Do we have the relationship between moles and the volume? We do have. Moles equal to what? Volume at STP over 22.4. We already know the number of moles of carbon dioxide, 0.5. Volume we need to find out over 22.4. So, this part I'm rubbing. Okay. So, volume is equal to 0.5 over 22.4, which is equal to how much? 11.2 liters. So this is how you find out different values from the equation. Okay. Now, this is the question we finished. Okay. So I hope by now you would have understood how to find out the number of moles, how to find out the number of atoms if moles are given, Avogadro number, etc. Okay. Now, based on these past paper questions, we will be discussing in the videos to come. Okay. Now, coming to the next topic, which is the limiting reagent. Now, students, limiting reagent, from the name itself, if I say limiting reagent means something that is any reagent or any substance that is completely used up. Okay. In a reaction is, for example, hydrogen and oxygen giving you water. Okay. We might take 50 grams of hydrogen or 50 liters of hydrogen and 20 liters of oxygen to give you water. As the reaction proceeds, maybe one of the ingredients or one of the reactants may be completely used up, and that substance is called the limiting reagent. Okay, and suppose if that substance, for example, hydrogen and oxygen, I said 50 grams or 50 liters of hydrogen is reacting with 20 liters of oxygen. Okay, so if this 20 liter of oxygen finishes, the reaction stops. It will not produce further product because one of the reactants is over. The reaction cannot proceed. So that means the substance that's a limiting reagent will help us to understand how much of the products is produced. Okay, so we will check out with the example and it will be clear. Right. Now, so that means limiting reagent is nothing but the substance that is, or the reactant that is completely used up in the reaction. And this limiting reagent helps us to determine how much of the product is produced. Okay, let's do an example. There's a series of steps that helps you to find out the limiting reagent. Right. So we'll illustrate with an example. Okay. You are given 10 grams of, so the question was there in the question was there in the PowerPoint. Okay, so you are given 10 grams of nitrogen and 10 grams of hydrogen. They are the reactants. Okay, so let's write down the reaction. Nitrogen plus hydrogen. In all these, we have to write a balanced equation. Okay, so this is 2, this is 3. This is the balanced equation. Okay, now you are given 10 grams of nitrogen and 10 grams of hydrogen. Okay, you have to find out the limiting reagent. I'll be using LR to denote limiting reagent. Also, this is the first question. The second question, how much of ammonia is produced? These are the two questions. Okay. Now, students, if you see 10 grams of nitrogen is reacting with 10 grams of hydrogen. Both are equal. But if you see over here, 1 mole of nitrogen from the balancing number, 1 mole of nitrogen is reacting with 3 moles of hydrogen. It needs 3 moles of hydrogen, 3 times. Okay, so there will be a reagent that will be completely used up. We cannot say that both the reactants are equal. So how can we run off? How can one of the reactants finish? Okay, we cannot say that, because here you have to see 1 mole of nitrogen is reacting with 3 moles, 3 times the moles of hydrogen. Okay, now let's check out how to find out the limiting reagent. First, write down the given masses. How much of nitrogen is given? 10 gram. How much of hydrogen is given? 10 gram. Okay, the nitrogen, the mass is 14, hydrogen is 1. Okay. Now find out the number of moles. 10 over nitrogen is how much? 14 times 2, because there are 2 of them, 2 nitrogen atoms. This is 10 over 2. Right. Now over here, this is 0.35. This is 5. These are the number of moles. Now, these are the steps. These you have to remember. First, write down the mass that's given to you. Next, find out the number of moles. Okay, moles you already know, mass over molar mass or the atomic masses. Okay, now you have to divide by stoichiometric coefficients. Divide by coefficients. 0.35 by, what is the coefficient over here? The balancing numbers. Instead of coefficients, I'll write divide by the balancing numbers. Balancing number over here is 1. What about hydrogen? What's the balancing number for hydrogen? It's 3. Right. Answer for this is 0.35. Answer for this is 1.66. Now, after this, compare which one is smaller number. Whichever is the smaller number, that will be your limiting reagent. So 0.35, 1.66. Which one is the smaller number? The smaller number is 0.35. So our limiting reagent, I've already told you I'll be referring to limiting reagent as LR. Okay. So our limiting reagent is nitrogen. Why? Because here when you compare, it has less number of moles. Right. That is our first question. That is A. Our B question is, how much of ammonia is produced? Okay. So for this, I have to write the reaction once again. 3H2 giving you 2NH3. Okay. Now over here, I will rub the steps from here. This I don't need now. I just need the number of moles. Okay. Now, 1 mole means the balancing number here. 1 mole is reacting with, what's the balancing number over here? 2 moles of ammonia, right? According to the reaction, according to the equation, 1 mole of nitrogen is reacting with 2 moles of ammonia. We already know the number of moles of nitrogen. So we will be using that moles. We will be using the moles of the limiting reagent. Okay, so here the limiting reagent is nitrogen. So we'll go about with the moles of the limiting reagent. Okay, so 0.35 will react with how much? Because once nitrogen finishes, the reaction is over. No more ammonia is produced. That's the reason. Okay, so we cross multiply. So X is equal to 0.35 times 2, which is equal to 0.7 moles. We know the number of moles. Can we find out the mass? Mass is equal to mole time molar mass. 0.7 times ammonia. Nitrogen is 14. Hydrogen is 1 times 3, that is 3, that is 17, which is equal to 11.9 grams of ammonia. This is our second answer. Okay, so these are the steps. Limiting reagent means the reagent that is completely used up. So these are the steps. First you write down the masses that is given, you find out the number of moles, and then divide by the balancing numbers, you will get the limiting reagent. After that, after you find out the limiting reagent, you need to use that mole to find out the mass of the product. Okay, so this is how you proceed. For the same equation, nitrogen plus hydrogen giving you ammonia, you are given 20 grams of nitrogen and 5 grams of hydrogen. You need to find out limiting reagent, and once you find out the limiting reagent, you need to find the moles of ammonia. We follow the same step. Nitrogen is 14, hydrogen is 1. Okay. So what is the first step? We determine the number of moles. Mass is given to you. 20 over ammonia is how much? 14 plus 3 times 1, that is equal to 17. Okay. So nitrogen is 14 times 1 times 3, that is equal to 17. 17. Sorry. And this is nitrogen, right? So nitrogen is how much? 14, right? Nitrogen is 14, hydrogen is 1. So 14 times, so nitrogen, I'm talking about nitrogen, sorry. Nitrogen is 14 times 2 because there are 2 atoms. So which is equal to how much? 0.714. Over here, hydrogen, the mass given is 5 over molar mass. That is equal to 1, but because we have 2 atoms of hydrogen, we take it as 2. 2.15. Sorry, 2.5. Okay, so these are the number of moles. What's the next step, students? We need to divide by the lowest number, divide by the balancing number. So what is the balancing number over here? Balancing number is 1. For hydrogen it is 3. So divide by 1, this divide by 3. We have 0.714, this is 0.833. Which is our limiting reagent? Whichever is less. So first answer is limiting reagent is nitrogen. It's so not always nitrogen, depends upon the amount given and the moles, okay? So in this case, we got it as nitrogen in both the cases. Now, what is our next step? We need to find the number of moles. So we don't want this step now, okay? We got our limiting reagent as well as the, 714. Okay, so we got our number of moles, 714.714. So we come to the, we write the equation, rewrite the equation once again, okay, 2NH3. Okay, so 1 mole, I'm choosing nitrogen because that's our limiting reagent. 1 mole of nitrogen is reacting with 2 moles of ammonia. So 0.714 will react with how much? So X is equal to 0.714 times 2, which is equal to 1.42 moles of ammonia. If they ask you for the mass, you know how to make the moles into mass, which formula to use. Okay, so this was about the limiting reagent. So you can find out the limiting reagent that is completely used up. Okay. And from there, you can find out the mass of the product. Now, students, limiting reagent, I have seen a lot of questions in the past papers. Okay, so we will be doing all those, as I told you, after the lesson is over. Okay, for now, please remember the steps as I told you. What are the steps, how to find out the limiting reagent. Okay. Now, coming to the next topic, which is molecular and empirical formula. Now, molecular formula, any compound, okay, any compound, in any compound, molecular formula tells you the actual number of atoms or actual number of elements that are present in the molecule of a compound, okay. And empirical formula gives you the simplest whole number ratio. Okay, so I'll just share the screen. Molecular formula of maybe hydrogen peroxide, H2O2. It will give you the actual number of atoms that are present. So how many atoms of hydrogen are present? 2 atoms. How many oxygen atoms are there? 2 oxygen atoms. Okay, that's the actual number of atoms that are present in the molecule of a compound. But empirical formula will give you the whole number ratio of the atoms that are present in the compound. For example, if the molecular formula of hydrogen peroxide is H2O2, how do you simplify it? Both are 2. Can I simplify it as HO? Because it's the simplest whole number ratio. Now, similarly, if the molecular formula of benzene, that's an organic compound, you will be learning about it, C6H6. So that means benzene has 6 carbon atom and 6 hydrogen atom. So that means it gives you the actual number of atoms that are present in the molecule of a compound. But can we simplify the ratio? After all, it's a molecular formula is nothing but the ratio of different atoms present. Okay, so 6 atom is to 6 atom of hydrogen. 6 carbon atom is to 6 hydrogen atom. So can we simplify it? The simplified version will be how much? CH. And the simplest whole number ratio determines the empirical formula. Okay, so that's why they have said molecular formula gives you the actual number of atoms present in the molecule of a compound. Empirical formula will give you the simplest whole number ratio of different atoms. Okay, now from here you can see the first relationship. Empirical formula times N is equal to molecular formula, where N is equal to 1, 2, 3, etc. That's the relationship, first relationship. Okay. Now, moving, just giving you a question. I'll be giving you some molecular formula. You need to find out the empirical formula. Molecular formula I refer to as EMF. Empirical formula I'll refer as EF. Okay. So molecular formula is C6H6. Next one is C6H12. Third one is H2O2. Last one is H2O. Okay. So molecular formula C6H6 means there are, sorry. The C6H6 means there are 6 carbon atoms and 6 hydrogen atoms, actual number of atoms present in the molecule. So what will be the simplified version? That will be how much? CH. Right? After all, it's a ratio. 6 and 6 ratio, right? What about C6H12? Can we write it as C1H2? Right? Instead of, we don't write 1. This is the simplified version. The simplified version is called the empirical formula. Okay, simplest whole number ratio of different atoms. So if the ratio, here the ratio is 6:12. What will be the simplest ratio? Simplest ratio will be 1:2. Here the ratio is 6:6. What will be the simplest ratio? That's what I have done. The next one, here the ratio is 2:2. What will be the simplest ratio? HO. Here the ratio is 2:1. What will be the ratio? It cannot be simplified further. We write the same thing. Okay. So this is how you find out the empirical formula if the molecular formula is given. Okay. And there's a relationship between them. Empirical formula times N is equal to molecular formula, where N is equal to 1, 2, 3, etc. Okay, and I'll tell you where to use and how to use now. Okay, now. Okay, so I just showed it in the form of a ratio also. Now. Okay, now the first question is, question number 1. This also a lot of past paper questions I have seen. Okay, question number 1. Sodium, a particular compound has sodium, which is 43.4%. Carbon is 11.3%. Oxygen is 45.3%. So whenever the percentages are given, you need to check whether the total percentage is coming to 100 or not. So that means 43.4 plus 11.3 plus 45.3% should be equal to 100. That makes the whole compound. Okay. If it doesn't come as 100, we have a that means we have one more element there. Okay, they would have given information. They would have given the information about that element in that question. Okay, for now it's coming to 100. Now the question is calculate EF. EF is nothing but empirical formula. Okay. Now there's a set of steps for that. Now sodium is 23. Carbon is 12, oxygen is 16. Okay. The first step is find out the number of moles by dividing the mass. The percentage is nothing but the mass by the molar mass. Okay. So 43.4 over 23. That's the first step. Always find the number of moles. 11.3 over 12, 45.3 over 16. Okay, so this comes to 1.88. This comes to 0.941. This comes to 2.83. These are number of moles. Now, after you find out the moles, you have to divide by least number. Which one is the least number here? 0.941. So 1.88 over point. These are the steps, students. Please remember the steps, okay? Because always the numbers vary. So it's not that the same question or the same percentages you will get. So please memorize the steps actually. So when you divide by the lowest number, all of them, all the elements, moles of all the elements, you have to divide by the least number, okay? This will be 1. This will be around, if this comes to around 1.99 something. So I assume it to be 2. So the empirical formula will be, how many sodium atoms are there? 2. How many carbon atom is there? 1. So we don't write it as 1, we just write it as C. Oxygen, how many atoms? 3. So this is how you find out the empirical formula. Okay, so these are the steps. First write down the masses that's given to you. If it's in percentage, write it as it is. Even if it's in grams, just write it as it is. Next, divide by the molar mass or the atomic mass to find out the number of moles. Divide by the least number and try to make it as a whole number, okay? And it will give you the number of moles, okay? The second question is, and also one more thing I told you, that you must keep it as a you must always try to make it as a whole number, like 1.99 and all, you can make it as 2, okay? Now, the second question is, you are given a compound with molecular mass equal to 90. So I'll just show you the question over here and then I will write down the details, okay? So I'll come to these formulas now, okay? This slide you have done. I showed you the ratio, right? The first question we have done. The second question, compound has a molecular weight of 90. An empirical formula is given to you. You need to find the molecular formula. Question number 2. Okay. Molecular mass is 90. I'm just giving you the empirical formula that is given. Okay. Empirical formula given is CH2O. Okay. Now, you have a relationship that I just showed you. Empirical formula, or rather, we'll go with this first. Empirical formula mass times N is equal to molecular mass. Okay, now empirical and empirical formula mass. Okay, now from here, can you find out the mass? Empirical formula mass. Can we find out the mass? Empirical formula mass. Carbon is 12, oxygen is 16, hydrogen is 1. Can we find out the mass? 12 plus 1 times 2 plus 16. How much is the empirical formula mass? Is it coming to 30? So can we use this formula? We know the empirical formula mass. Molecular mass is given to you. Can we find out N? I'll tell you why. Okay. Empirical formula mass, I'm using this formula. Empirical formula mass is 30. We just found out now. Okay. Equal to times 30 times N equal to, what is the molecular formula mass that's given in the question? 90. So N is equal to 90 by 30 is equal to 3. So N is equal to 3. Okay. Now we have another formula with us. Empirical formula times the same formula, but this time we are using the formula. Empirical formula times N is equal to molecular formula. So what's the empirical formula that's given to you? CH2O times, so this is the, as I told you, empirical formula is the simplest whole number ratio, right? If we multiply with a certain number N, it will give you the actual number of atoms. Okay, so that number is this 3. Okay, times 3 will give you what? The molecular formula, which is nothing but C3H6O3 is nothing but the molecular formula. So we have used this formula, empirical formula, mass times N is equal to molecular mass. We can find out the number N, which is nothing but the ratio number N. Okay, with what number we can multiply the empirical formula mass? With what number we can multiply the empirical formula to give you the molecular formula? Here it comes out to be 3. Okay, and then we can find out the molecular formula. Now, we will do one more question on this. Question number 3, if you see, again, compound has a vapor density of 45 and empirical formula is CH2O. And the vapor density is 45. Now, whenever vapor density is given, I've given you a hint. The molecular weight you can find out by multiplying the vapor density with 2. Okay, so let's check out. So I've written down the information what's given. Vapor density is equal to 45. So I just gave you the hint. Vapor density times 2 will give you what? The molecular weight. So vapor density is 45 times 2, which is equal to 90. That is the molecular weight. Now it's the same way as you did the previous one. You know the molecular weight, it's 90. What is the empirical formula mass? Carbon is 12, hydrogen is 1, oxygen is 16. So 12 plus 2 plus 16, it comes to be 30. So you have the molecular weight, you know. You also know the empirical formula weight. So what formula you use? Empirical formula mass times N is equal to molecular mass. So can we find out N? So 30 times N is equal to 90. Did we find out? 90. So N we find out, that's the ratio number with which we multiply the empirical formula to give you the molecular formula. 3. So it's the same question in different ways. Okay, so the vapor density, please remember, if you multiply with 2, you will get the molecular mass. So you have CH2O times 3. Which formula we used? Empirical formula times N will give you the molecular formula. We know the empirical formula is CH2O times, what is N? 3. C3H6O3, which will give you the molecular formula. Okay, so this is how you find out the molecular formula. Let's do one more question, and this happens to be one of the past paper questions. Okay. Now, a compound has 32% of A, 20% B. See, I mentioned percentage, and the remaining is C. So, if the mass is expressed in percentage, we have remaining as C. So, can we find out C? This is A, this is B, 32, 20. How to find out the C? C we can find out C by 100. We assume that the total percentage of a compound is 100, of all the elements together is 100. 100 minus 32 plus 20, right? So 100 minus, how much it is? 42, which is equal to 48. So we got 48%. So now the steps is the same. Find out the number of moles, and in the question they have mentioned A, the mass is 64, B is 40, C is 32. They have mentioned in the question. This is one of the past papers, and they have, because they have not given you the symbols, they have mentioned what is A is 64, B is 40, and C is 32. Okay, this information is given to you. Okay, now, so for that we need to find out the number of moles. Moles is how? 32 over 64, right? Mass over molar mass. 20 over 40, 48 over 32. Okay, so we get it as 0.5, 0.5, and 1.5. What is the next step? Divide by the least number. 0.5 by 0.5. This is, if both of them are least, never mind, just move on. 0.5, right? This is 1, this is 1, and this is 3. So what will be the formula? A, B, C, 3. This is the formula. Okay, so these are the steps. Find out the number of moles, divide all the moles with the least number of moles. That will give you the formula, right? So see, as I told you, this is the question. In the question itself, they have given you the atomic masses, and what you find out is the empirical formula. Okay, if they have given information about molecular mass or something like that, we can find out the molecular mass. But in this particular case, they have only asked you to find out the empirical formula. So what are the steps? Find out the number of moles, divide each of the moles with the number of with the least number of moles. Okay, and it will give you the empirical formula. So students, these are some of the questions that we practiced about stoichiometry, stoichiometric equations, moles, limiting reagent, percentage, composition, molecular, and empirical formula. In between, I have tried to include some of the past papers questions from NEET and JEE. But after as I told you, after completing the whole lesson, we will definitely do more questions on these. Okay, first, what is important is finding out the steps. I mean, remembering the steps and the formulas. Okay, so that's it for today, students. Thank you and have a nice day.